Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hallo, liebe Zuhörerinnen und Zuhörer, willkommen zu einer neuen Folge unseres Podcastes Robotik in der Industrie. Mein Name ist Robert Weber und ich muss euch ehrlich sagen, es ist so viel zu tun. Helmut war die ganze Woche Logimat, ich war auf European Robotics Forum. Wir kommen gar nicht mehr zum Aufnehmen. Wir wollen diese Woche, also die vorletzte Woche im April, eine Folge aufnehmen, um so ein Recap zu machen. Da haben wir auch wieder keine Zeit gefunden. Ich bin in Linz, Helmut ist wieder irgendwo anders auf Dienstreise. Deshalb haben wir heute eine Folge uns bei Peter beim Industrial AI Podcast geklaut, nämlich mit den Kollegen von Voraus Robotics und wie ein Agent eine Robotikzelle managt. Das ist eine super spannende Folge, hört gerne rein. Übernächste Folge gibt's dann was von den Neura-Kollegen, dann kommt Bain und dann hoffentlich können Helmut und ich auch endlich mal wieder eine Folge gemeinsam aufnehmen, wenn wir uns irgendwo mal wieder treffen. Also bis dahin, bleibt gesund, viel Spaß bei der Folge und tschüss.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seberg and I'm your host. Today I'm going to be talking to Tobias Ortmeier. He's the co-founder of Voraus Robotics. And Tobias and I are going to be talking about AI agents in automation. Hi, Tobias.
Hi, Peter. Thank you very much for inviting me. It's a pleasure.
You're very welcome. At the beginning of spring, as we just said already, where you're living, where I'm living, after many, many months of big cold, we see the sun shining, right?
Finally. So summer can come.
Right. Yeah, we're looking forward to it. Tobias, please introduce yourself to our listeners.
Oh, okay. Introduce myself. So, as you just said, my name is Tobias. A long time ago, I studied electrical engineering basically in Munich, so the town where you come from.
All right.
At the Technical University. And well, after that, I had the pleasure to join the German Aerospace Center. So maybe you even know that it's in Oberpfaffenhofen, so very close to Munich. And I think that's one of the best playgrounds for engineers. So they have all these nice facilities. And I joined the Institute of Robotics and Mechatronics. So this was at that time headed by Professor Jetzinger, a well-known roboticist. In this institute, the foundations for lightweight robots were developed because they wanted to bring robots into the space, and every kilogram of payload costs a huge amount of money. So they began to develop lightweight robots. And unfortunately, I was not part of that development, but I had the chance to be part of the medical robotics group. So we took these technologies and tried to transfer them into the operating room. So this was basically for the first 12 years of my professional journey. Then I went to KUKA. KUKA is nearby. It's in Augsburg, one of the biggest robot manufacturers. And once again, I was doing robotics for medical purposes. But this time it was for patient positioning. So if you do radio surgery, if you have a tumor, then sometimes it's easier to position the patient in front of the beam with high accuracy than deflecting the beam with very big magnets. So we were doing that. There are some installations worldwide, but I hope you never experienced that.
Well, actually, yeah, don't talk about it. Rather not. Brings back certain memories that maybe I would rather not want to have. But nevertheless, it's very important work, yes.
Then I joined the Leibniz University in Hanover. So I'm still located in Hanover. And I had the chance to become a full professor at the Faculty of Mechanical Engineering, heading an institute for almost 12 years. And at the end of 2020, I left university. So that's quite unusual, to be honest. So my wife was not so sure whether it's midlife crisis or what's happening here. But if you're a professor, you're doing a lot of paperwork. So you're writing proposals, you are reading theses, you are applying for grants. So a lot of paper, and the fun thing, technology is becoming less and less important.
That's what your students do or not, right?
Yeah. That's what students do, but that's also what I like to do. And that's why I left university. So it was, to be honest, not an easy decision. And then I had the chance to join once again a company developing robots for minimally invasive surgery. So we did the entire rough journey, obtaining CE mark, bringing the system into the hospitals. And then in 2023, I joined Foraus Robotics, or Foraus Robotic, and where I am, as you just mentioned, a co-founder. So that's my professional experience in a nutshell. And I still enjoy teaching. So that was the fun part, being professor.
Very good, and very good sharing already at the very beginning your midlife crisis with us, out of which in the end came what it is we're talking about today, I guess. So tell us a little bit more. Obviously, the words Voraus Robotic are two, well, at least the first one is a German word. The second word our listeners worldwide will recognize as robotics, I guess. Tell us what the words stand for, and tell us a little bit about the company. What does the company Voraus Robotic do?
Okay. So if you found a company, I think one of the toughest things you do at the beginning is how to name it, right? So how to brand it. And we had discussions with brand agencies, and we were not so happy. Suddenly the guy came around the corner with a very good idea. He said, well, you're always talking about being ahead of competitors, being at the edge of technology. So, and in Germany, being ahead, that's Voraus. And then he just said, okay, then name your company Voraus Robotic. That's it. And you get used to it.
As easy as that. And what kind of robotics does your company deal with? You just talked about you have been doing a couple of medical environment robotics. What does Voraus Robotic deal with?
Okay, so we are in a completely different space. So we are in the industrial automation space. And yeah, as the name may suggest, so we started with robotics. That's right. But now we are tackling the entire automation space. So if you would like, I can, or if you like, I can give you some background information. What happened during our go-to-market journey?
Please feel free.
Yeah. Okay. So basically, the roots of Voraus Robotic go back to Yuanda Robotics. So Yuanda Robotics was founded in 2017, if I'm not completely wrong. And within Yuanda Robotics, we developed a cobot from the scratch. So really doing layouts, doing firmware development, low-level control, all these things. And I think one of the best decisions there was that we used Python as programming language for the application layer. So we did not come around the corner with another vendor-specific programming language because we thought we had no chance. So I don't know, Yuanda robot language, nobody will learn that. But Python, there are a lot of people out there who can program Python, millions of people. And then in 2022, we had the chance to do a management buyout. So what we did during that period is we sold the hardware assets. I think you know the company. It's Agile Robots, also located in Munich, but we kept the software stack. And then we had the maybe at the beginning naive idea that everybody is waiting for a new robot operating system. And when we talked with potential customers, the Python programming was really very well appreciated. That, okay, that's what we are looking for because it unlocks millions of possible developers, and we don't need to pay a huge amount of money for KRL courses offered by KUKA, for example. But then they always asked us, okay, so with the robot, that's fine. We understood this. But what about the rest? What about the conveyor belts? What about the drives? What about the sensors? And as a lot of customers asked these questions, we realized, okay, just looking at the robot is not enough. And that's why we started to integrate software stacks for real-time field buses. So, for example, Profinet or EtherCAT. And then suddenly you can program the entire automation. You can program all components in high-level programming languages. And there is no difference more between a robot, between a conveyor belt, and between your application. So it all comes together. And that was basically, I think, the key to unlock a huge market. And unfortunately, our name is Voraus Robotic. Maybe Voraus Automation would be better, but we keep it that way.
Okay, and that's how we then move to thank you very much for that great detail, also with reference to Python. And we just visited actually Amsterdam with our Industrial AI podcast team of people in Amsterdam. And we did explicitly go to the Centrum voor Wiskunde. I'm Dutch. That's the Center for Maths, where Guido van Rossum over a weekend developed Python. But that's more on the sideline. So AI agents in automation, how beneficial is AI in industrial automation today, and what are the prerequisites? That's the title of the paper that you, and I guess with some others, wrote. Just as a quick spoiler, just a yes/no answer. Is it beneficial?
Yes, I do think so.
Good.
Oh, that was actually good.
I only wanted a quick no. So that's the spoiler. So those of you listeners who are interested in the topic, you now know that we're going to be talking something that is actually beneficial. But before we get there, your paper is the next in a series, and the one that is preceding this one was called Industrial DevOps. Just very quickly, maybe in a couple sentences, what was that about?
Okay, what was that about? So basically, it was about the merge of IT and OT.
Okay.
And how we can bring this, let's say, fantastic tool chain we have in the IT world, with automated testing, quick deployment, how we can bring this into the automation space.
Okay, very good. Just for those people interested in the topic we have today, AI agents in automation, that they know that you have been, where you are coming from, and that there's other things to be reading as well. So give us a first quick introduction into the paper that we're talking about today, AI agents in automation.
Okay, so let's put it that way. We started with some challenges. So what are potential obstacles? What are risks if you use AI or AI agents in the automation space to generate or to optimize code? And how we think that you can overcome those obstacles. So, I mean, basically, that's the let's say, more theoretical part. And then we have some case studies where we really implemented AI agents doing things autonomously or interactively with the user.
Mm-hmm. Okay, yeah, and that's what we're going to be moving into slowly in more detail. Now, in your paper, you just mentioned AI or agents. I guess whatever we're going to be talking about will use, or you will use the correct wording as it is relevant. But somewhere in your paper, you do talk about the use of generative AI. I'm not sure that is still the big topic today, or maybe it is, but remind us, what is generative AI, or what is it in as relative to the topic that we talk about today?
Okay, so the way we use AI agents, generative AI is, let's say, one of the core components. So you have an AI agent that is, for example, gathering information via Model Context Protocol, for example. It feeds the generative AI, those are large language model. Then some output is produced. And then we use this output together with the AI agent, and the agent runs, for example, a simulation and performs some tests. And then with the test results, the AI agent can evaluate whether, my theory how to modify the code was correct or not, and maybe how to modify it.
The picture I kind of paint in my brain is that, and maybe I've been thinking about this for a long time myself, so the agent is maybe like more the user interface. So whenever I talk throughout the day, more and more, I like to talk to my smartphone in this case, and I use the words of whatever big high-tech company, and the thing listening maybe, question to you, maybe the agent, and the agent goes, typically, if I want to know something, goes onto the internet maybe, or has already pre-filled in answers, I don't know. So, or the other way of saying it is like, is the agent maybe the user interface in a car? It's like the steering wheel and the brakes, and it goes, and whatever I do with the agent goes into the engine, and the engine would be more like the generative AI, or is that too easy of a representation?
I think so. My, let's say, picture I have in my mind is that the AI agent is orchestrating everything. So you have different user interfaces. So that can be, coming back to your car, it can be the steering wheel, there are the pedals, there is the infotainment system. So you have different input modalities, and the AI agent just collects this information. And then the AI agent starts a, let's say, thinking mode, retrieval mode, and then orchestrates everything. So maybe it needs additional information from the map. So is there, let's say, a corner or a steep curve ahead of me? Do I need to decelerate, for example? So that's my perspective. And then it performs actions. I just wanted to say, and currently the action is mainly producing some, I don't know, some code. It's some slides for presentations, some nice Word documents. And now I think we are stepping into that field that AI is really doing things.
Even doing things in automation. And that's what we're talking about today. So what then are, let's say, particular challenges of, let's say, AI in general, or the Gen AI, or the agents in the environment of industrial automation?
Okay, that's a good question. Short question, long answer. So I try to keep my answer short too. Okay.
No, feel free.
Sorry for that. So maybe if we look at high level perspective, how generative AI works. So you have a certain input that is broken down into smaller pieces. So usually those pieces are called tokens. And then based on these tokens, an output is generated based on probabilities inside the network, the large language model. And these probabilities are usually trained with data the big companies gather in the internet or in GitHub or whatsoever. So it's an optimization. So I think that helps to understand where we think the challenges or risks come from. So I think that the first thing is that it's about security, reliability. So the more information you have in the internet for a specific topic, the better you can train those probabilities inside the network. And the more data you have, the better the output will be. Or the other way around, if you don't have enough input, then your network tends to hallucinate. So it will make things basically up, just to please you. So to produce an answer. I think that's my feeling always. If I work with large language models, they are people pleaser, right? They always say, "Oh, I'm sorry. Yes, you're right. I missed that. I did that. Yeah, sorry. Please excuse." So they are trying to please. That's my personal feeling.
I have two questions to that. I think number one, they are not built to please. I think they're number one, just as a start. That's at least my feeling. So when they were not. When they were making these mistakes, they were just making them because they were an algorithm and they had no idea what they were supposed to be doing. Number two reaction is that since a couple of months, when I use, and in this case, I just name it, it's the Google, it's the OK Google, it's the one that sits, I think, is the Gemini. But I'm sure that all the other ones are very similar, a little bit better, a little bit less. So that's completely the quality, not of what is being said, and we know, but what the contents of the answers are very, very, very high quality. And I think for the last 3, 4, 500 answers, I mean, you never know for certain, but I haven't seen a single, even smallest hallucination. Now, the question that I want to relate to that to you is that, and we had the hallucinations in the past. Now, is it, for example, the agent, can you use an agent to just improve the quality of the answers being answers, or things that the agent needs to do by the agent just going and checking at places or whatever? Is that combination, does that help us to improve the quality which we're going to be moving towards?
So sorry, I think you just lost me a little bit. So the question.
Oh, that's impossible. Sorry that happens. Sorry to you, dear listeners, as well. Yeah, but I think what I'm saying is, if you just use the plain algorithm, just going for the next token, then I think you're always going to stay at the potential of the algorithm giving you something that is bullshit. Now, if you're going to put an agent in front of it and you're going to look at the first answer, and maybe you get a second, maybe you get a third answer, and then maybe the agent is going to go onto the internet and make itself smart, or the agent is going to go to look to what has happened the last 24 hours in your production environment. The agent can do 1,000 different things within seconds, and then we'll talk about later on determinism and stuff like that. But the agent doing all these things can make sure that all these potential answers, before giving them to the user or before doing something in the industrial environment, is going to be 99.9999 correct.
I would say yes and no.
Yeah, that's okay. That's okay. That's why I'm asking.
So I'm totally with you. So I mean, there are even AI agents which use the prompt for an internal prompt to expand your prompt to make it more precise. So these things really take place, and of course, AI agents can double check the output, as you just said. They are producing an answer, then retrieving information from the internet, and then look whether it matches or if there are some loopholes, some flaws, whatsoever. Yeah, I'm totally with you. So this helps to increase the quality of the output.
Now let's look at, as you said, IT-OT combination. That is a topic that has been around for a long time. So how can AI, GenAI agents, how can they help us in existing IT-OT landscapes? How to integrate it?
I think that, of course, they can help. I'm with you. But I think they are not as beneficial in existing IT-OT landscape as they could be in general. So why is it? So if I look at a, let's say, simple automation cell, so let's say, pick and place with a computer vision to detect some goods in the conveyor belt. So I have several proprietary programming languages. So I have structured text for the PLC. I have a vendor-specific language for the robot. Then I have something maybe for the smart cam. And usually, as I just said before, especially for robot-specific languages, the amount of training data, it's very low. So the output, the agent or the large language model produces may be not as good as we just discussed because of a lack of information. And the other thing is that, of course, I can test parts. I can generate a code for a robot, for example. I can generate something for the PLC, but I'm caught in silos, so I cannot test. I cannot take a look at the entire automation cell. And I think that's very challenging for AIs. Every vendor has some specific simulation environment, some specific language, and then producing or optimizing code with industrial grade is, I would not say it's not possible, but I would say it's very difficult.
Sure. Now, in your answer lies a, question, a hope, a suggestion that and maybe the topic is brownfield, greenfield, right? So if we're we were talking existing, and that's maybe not that easy. So does that then mean that within the greenfield environments, AI agents, GenAI is going to give a higher potential? And maybe you can talk about in what direction maybe there could be a real potential.
Okay, yes, that's always the easier way if you have a greenfield approach, because you can make, or you have the chance to adopt things in a way that eases the work for the generative AI. And I think there are several possibilities or several ways to go. So the first thing is, and we are at Voraus, of course, not the only one, but the first thing is that let's break down the silos. So let's move away from these proprietary languages, use high-level languages for your entire automation, so for the control of the components, for the application. Because then really you unlock the power of large language models to really understand and improve your code, or to generate new code.
Are you saying, as an example, instead of the typical PLC ladder programming, use whatever Python-based control as an example?
Yeah, because I think then you have really you benefit from the data available. Yeah. The other thing is usually every cell, let's say, has a different control topology. So sometimes it's the PLC which is coordinating everything. Sometimes it's an edge device. In smaller cells, it may be the robot which is the master of disaster in the cell. So, and this is also very, very difficult for an AI agent, because the code the agent is producing needs to take the specific topology into account. So it's from an AI perspective, I think it's much easier if everything is centralized.
Sure. Okay. Well, yeah. And in general, sure. I mean, a greenfield, you can always use the latest, greatest available technology, right? Maybe we'll discuss it at the very end. As always, I'm going to be asking you how you see the next 5-10 years, but only at the end. And it, of course, does include let's say we have globally, let's say 100 million production sites, and 99% of them are by definition brownfield, right? So, but we'll do that later. So I think so far we've been talking, let's say, more theoretical. At least that's how it's was supposed to be. And as for now, moving into the case study that you have been dealing with, maybe give us a quick introduction into the case study, and then we're just going to be talking about what has come out of that case study specifically.
Okay, yeah, thank you. So the case study we set up in a simulation environment and in our lab is a pick and place cell. So we have 3 boxes with small plastic items, plastic bags inside, a robot with a vacuum gripper, a smart cam, conveyor belt. Basically, that's it. And the smart cam detects the bags to be grabbed, and the robot places them on the conveyor belt. And as this was, as you just said, a greenfield approach, so everything is controlled, centralized by one IPC. So there is no PLC integrated, so no structured text or ladder programming, as you said, even down to the field bus level. The entire cell is controlled by, we call it the Voraus core, which is our control software.
Right. And just as an understanding for terminology, when you say there's no PLC, there is a software. I mean, there's an IPC, which has some kind of processor like a PLC has. And so instead of a typical gray box that we call PLC that we buy, there is an IPC, and on that IPC runs some kind of software. So it's more like a software PLC. Is that correct?
No, sorry.
Well, very good. That's why I ask.
So there is no soft PLC, or there is no how do you say, virtual PLC. So really everything, including the commands for the drives, is programmed in Python or Rust.
Okay.
Yeah, so it's only one gray box, the IPC.
Right. I think the reason you push back is that the term software PLC is used by the companies, the automation companies selling PLCs, and these days are moving into selling software PLCs as well, right?
Exactly, yeah.
So that's more like, so the Siemens and all the other big companies, big automation companies that have been selling the boxes are now as well, and in addition, selling what was inside of their box as a software solution. And you say that is not what you say explicitly. What you have is Python based, right?
Exactly. It's Python, it's Rust. Yeah, exactly.
Very good. Now, what have you been doing with your setup, with your case study, moving into, the agents and answering the questions? Are AI agents already useful today in an industrial automation setting?
Yes. So I think in this podcast, there are 3 use cases which may be of particular interest. So the first use case is that you're always unhappy with the cycle time. So it's always too slow. The output is not enough. So our first use case was, okay, please increase the cycle time and do it in a fully autonomous mode. So without any user interaction. And the second one was do the same thing, but with user interaction. And we will maybe see later on that indeed that makes a difference. So the human can bring in some expert knowledge. And the last use case we may talk about, if you like to, is generating code fully automatically. So that means really from the scratch. There is no existing code which is optimized, but do it only with prompting.
Okay, sounds great. Let's get into all 3 of those, and please explain them, by more detail. And of course, in the end, we want to know what your approach brought. So, the first one is reducing the cycle time, right?
Yes, the cycle time in a fully autonomous mode. So we set up an AI agent basically on Git. So as you said before, it was a Gemini, so from Google. So this one, or the AI agent, sorry, to be more precisely, the AI agent used Gemini 3 as a large language model for code generation. And this AI agent was granted access to the existing Python code. So somebody already wrote the application. So maybe that's more as you said, the brownfield approach, something is already here. So we've got access to the Python code, access to our documentation, which at that time, to be honest, was not AI ready. So we just refactored it, but maybe that's a side topic. And then via the model context protocol, the AI agent was able to retrieve information from a influx database. And this database was fed by the simulation where we check for collisions, where we can measure times, where we can see whether something is within the workspace of the robot or not. So maybe that's one of the core topics. For this application, we run a simulation, and the simulation is used for testing. Then, of course, prompting. Prompting is the next topic here. Of course, the prompt included the objective. So please reduce the cycle time. We told the AI agent which parameters he may change and which he should not touch. We also asked the AI agent if he feels the necessity to produce additional tests for the test plan. Yeah, basically that was the prompting. And then there is a so-called funny word beast mode. So where the AI agent really can execute the code that you say he or she is generating.
I was going to ask you, I heard you say he.
Okay.
That's a topic that has been with us for as long as we do the podcast. If we're calling an algorithm an it or a he or a she, the one that I use on the same platform I just mentioned is a female voice. So I happen to call it a she, and you just called your agent a he. Yeah, I think we're going to find our way around there.
Thank you. So basically, the code is executed. Let's put it that way. But in simulation, not in the real cell. So in simulation, there is a physics engine included. It's open source. I mean, that's the quick win if you do Python. And the test plan is executed. And then the AI agent sees, okay, if I do modify the path planning, for example, do I have collisions? Yes or no? Is the new path within the reachability of my robot? Does it affect the cycle time? So do I get faster? So it's testing the hypothesis, collects the information, and then does the next iteration. So, and we let the AI agent run, I think it was 10, 12 times, something like that, less than an hour. And then the optimization was finished on a standard computer, where you start the software container, you start the simulation, and so on. So very short period of time.
And the result of your test was?
The result, okay, the cliffhanger. The result is that within this few minutes, we got a reduction of the cycle time of about 10%, which I think is, given the time needed, quite decent. Yeah, that's good.
Most certainly, any, and that's rather remarkable. Yeah. So that's the first one. And one specific question, as I was reading through, I did see that you go via the MCP protocol. And just we've been talking about MCP in the past. We're going to continue to do that or not. Depends a little bit your perspective. Today, your experience with using MCP, is it going to be the or one new standard, or was it more like a shorter lifetime thing?
Oh, so predictions are always hard, but I think it makes things easier, definitely. Because you only need to talk to the MCP, and then the MCP talks to a service which has a certain interface, but you don't need to implement an API for each service you're interested in. You just talk to the MCP. So, and usually if things are making your life easy, they tend to stay. So I guess it's more on the long term. Yeah, we will see this more often, but that's my gut feeling.
I was going to ask in the beginning where I skipped it. Since a couple of weeks now back, Peter Steigenberger, the creator of OpenClaw, and it's just that I recall that he says he doesn't like MCP. He prefers CLI, which I think stands for the command line interface. But that does not mean that what I want to say is that was just one voice I heard. But you say, yeah, you expect it, at least you're happy with it as what you're doing. So they're just.
Yeah, let's put it that way. We are happy with it. Yeah.
Very good. Let's move to the second specific use case. As you said, that is the one where you do the not fully automated, but the interactive code optimization.
Exactly. That's what we did. So it's more similar to a, let's say, coding assistant, right? So the AI agent proposes things, makes some modifications, and then modifications are highlighted. And you as the user can say, okay, now please run the simulation. You see the results, and then you can adjust your prompt. You can say, okay, maybe use this parameter in addition, or maybe do it a little bit more that way. Because I have, based on my experience, I think it's a better way to solve the problem.
Right. Based on my human experience.
Exactly. Yeah. Sorry.
Yeah,
based,
okay.
yeah.
No, that's
based on my human experience.
Sure.
Basically, I don't remember the exact amount of minutes, but I think it was one hour approximately, so 60 minutes plus minus. And more interestingly, the results were much better. So the beast mode, the fully automatic code optimization, gained 10%, and the interactive way we gained 16%. Yeah, it was much better, 16%. So lucky for us, a good experienced user can make a difference.
At least for the moment, okay.
At least for the moment.
Lucky for us, at least for the moment. Okay, so two numbers we have, I think 10%, 16%, and then there's a third a third use case you were going to talk about, right? Which is
so we tried to do a fully automated programming. So we just tried to explain the task in natural language, and then we expected the AI agent to generate the code from the scratch.
How is that different from what you call the beast mode? So it's at a higher level even, or?
The beast mode, in the beast mode, the AI agent had access to the code already implemented by a person,
okay.
and the task was
right.
to optimize this code.
Oh, right. Okay, I'm with you.
To look for some velocity gains or possibilities to reduce time. And here the task was really, that's what I want to do. Please generate the entire code.
Oh, no, I'm very much interested in what was the outcome of this one.
So were we. Let's put it that way. I would not say it's not possible, because there are companies out there trying to do this for very specific, dedicated applications. But we were not happy with the results, given a reasonable amount of time. So happy with the results always means that we expect industrial grade code, which means code that is documented, which covers all the edge cases, which passes the tests. And unfortunately, that did not work in the period of time we reserved for this task.
Okay, good. But is there a but or is there not? I mean,
of course, there is a but. So what worked very well indeed is we implemented it for one box. And then we asked the AI agent, okay, so this is an example for one box. Now please complete the task for all three boxes. And this worked very well.
Okay.
So our feeling is that starting from the scratch, you need to provide much more precise information. You need to prompt the do's, the don'ts, the requirements, and this takes a lot of time. And I think if you have enough time, it will work. But for us, our experience was, okay, do a simple example and then use this as the basis to generate the entire application. That worked much better.
So this is the continuous story regarding context, I guess, right? And is it about? I mean, is it about making it available at the very moment that it needs it, or maybe in combination with, let's say, foundation models, and then we talk about industrial foundation models, and then we talk about just all the information that your specific customer, has gathered in the last 50 years, or that's a long time, but maybe it's 25 years, in this one specific plant. And then the other 100 plants around the world, there's like, is it also related to making all that information available as if it was like in a foundation model? So providing more and more context, not only at the very second we need it, but just in general.
I think in general, context will definitely help here. I mean, it's just a question of training data, context, information, which can be retrieved by the AI agent. I still have some doubts, to be honest, at least at the short or midterm perspective. So I think it can work for, let's say, more simple applications, machine tending, for example, or spot welding. But if you have a complex automation cell, I think they are all different. And taking then the edge cases into account. So what happens if a sensor fails? What happens if, I don't know, I have a leakage in my pneumatic system? All these things need to be somehow considered in the application or in the program I'm writing. Maybe it will work, but not tomorrow. Let's put it that way. I'm still a little bit skeptical here.
Yeah. Now we're in the middle of what you said is so difficult, forecasting, and so we are moving towards the close of our podcast, which is then always about, where is this going to bring us? And if I bring back together in my brain what I just heard in the three specific use cases, the combination of human and agent is better than only the agent improving the existing solution. and having the agent do things in an industrial environment just from speaking to it or just telling it what to do does not yet work. Maybe it works for a small piece. Now, if that is correct, and if I say I don't care, it's not that I'm looking for, getting all our listeners and all the other ones that do not listen, that do program our industrial environment out of a job. Not at all. It's more the other way around, right? We're moving. We already have today many, many times not enough people to do this work. And it's only even the next 10, 20 years. I know here in the German market it's going to be worse because the people who've been doing this 40, 50 years are going to just be leaving their job. Now, so where does this leave us then? You just started to forecast. Where do you see, with the knowledge that you now have in AI, GenAI agents, what is going to happen? What can they do in the next couple of years? And how is that going to help us in wherever your customers are or globally?
Okay. So I think if you want to exploit the full benefits of AI, you need to rethink the way you do automation. I mean, we discussed this at the beginning, centralized control, no proprietary silos, no specific tools, make things open, make it accessible via high-level languages to the AI agents. I think that's one of the most important things, because this does not only ease the task for the AI, but it also unlocks a huge amount of programmers. So if you compare the number of people that are familiar with robot-specific languages and the number of people that do Python or Rust or even C, there are magnitudes of difference. And also from an age perspective. So, I mean, all the young people leaving, I don't know, university or high school. No, high school is not the correct wording, but let's put it that way. Leaving university, they all know high-level programming languages. So I think this is one thing also to tackle the demographic change.
Okay, so open includes the word open source. I mean, I assume, what you talk about, if you say Python and the other ones, I mean, typically open source solutions.
Not necessarily.
Yeah, I hear, but okay.
Open in my thinking means use standard interfaces. So don't lock everything inside, as I just said, into proprietary tools, which cannot be accessed by third-party software or by AI agents. Does not necessarily be everything open source. Of course, open source is very, very powerful, especially from a tool chain perspective. I mean, there are things open source like physics engines, simulation software that's incredible. So why not use it? You don't always need to reinvent the wheel. But once again, here, high-level programming languages, standardized interfaces is the key to get access.
Very good.
The other thing is we will see, that's my strong belief, we will see much shorter update cycles, especially the Cyber Resilience Act is just around the corner. So we will need to find a way how to deploy software very quickly and with minimum risk. And I think here simulation testing is very, very important. If you look, for example, at the websites of the big online shops, they do updates of their websites several hundred of times a day. Nobody notices it. And I think in the automation space, of course, not 100 times a day, but regular updates will become a must, especially based on the Cyber Resilience Act, where you need to react if you have some security flaws. And how to do this? And I think it's simulation and testing. And if you're able to simulate your automation cell and test whether a new piece of code or a change may introduce some, let's say, some collision, and you do this in advance, this will be, at least my perspective, the other main driver for AI agents. Because if you code manually or by AI agents, from a testing perspective, it doesn't make any difference. You need to test anyhow. So those are my two key takeaways.
Very good. Right. And in the end, bottom line, AI and agents do help us to deliver the value that we're looking for, right?
Short answer, yes. Exactly. Yeah.
Let's tell us a little bit more about your team, the people around you. Where are you based? Are you looking for talent? If so, what should they bring? Maybe there's one or the other listener interested in joining you and your colleagues.
Okay. Yeah, thank you. So we are based in Hanover. So not in one of the, let's say, high-tech hotspots like Munich or Berlin. So we are based in Hanover. As part of our team comes from robotics. So we are really OT experience. So we cover everything from hard real-time control to field buses. And we, as maybe this can somehow be sensed, of course, though we are doing all these Docker, Kubernetes, high-level things too. So I think our team really covers OT and IT. And I think that's very, very outstanding. So currently we have approximately 30, I think, 30 full-time employees. Maybe also as a side information, which is quite unusual, we are not VC funded. So our company is fully management owned. We are not VC funded because we think in the automation space, you need to be very close to your customers. You need to really understand what's going on. And you need some freedom. For example, VCs always think about recurring revenue, SaaS, and we know that this is possible, but it takes some time. So we decided to do everything on our own. So we are bootstrapped. Maybe that's also an important side notice here. Yeah, and of course we are always looking for talents. So we have our website accepts applications. So everybody is happy to drop us a line. So happy to get in touch.
Very good, Tobias. Thank you very much sharing your perspective on the benefits AI agents, GenAI are providing already today, and maybe even more so in an industrial automation setting. Thank you very much.
Thank you very much for inviting me. It was a pleasure.
You're welcome. Bye-bye.
Bye-bye.
Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber.